That's all right. I generally have a tutoring session that I like to give all new trig students.
Okay.
And it has to deal with how to memorize the unit circle. Now, you
Okay.
probably haven't gotten there yet. That usually
No, I don't think
comes
so.
in maybe the second week of trig. Um,
Mm-hmm.
and maybe we can wait for that. I see you've scheduled a session for Wednesday also.
Yeah.
What kind of stuff do you have that they've given you so far?
Um, Kind of just trigonometric functions and such.
Okay.
So,
Well, let's start with what you said. Sohcahtoa. Hold on a second.
okay.
There's trig is a lot more memorizing than precalc.
Okay.
Okay, and there's certain things that you definitely want to memorize.
Okay.
And everything that I'm drawing on here is such.
Okay.
You're familiar with these two triangles. They've been teaching you
Yes.
two triangles for 3 years.
Yeah.
These two triangles, and when I dimension it, it could be these dimensions or it could be 2, 4, 2 root 3. In other words,
Okay.
a multiple of these. I call these the two unit special triangles because what
Okay.
these two triangles do is it lets you figure out all trig functions of angles 30, 45, and 60.
Okay.
And then the next step is to figure out angles that are greater than 90 degrees. In other words, if I said, what's the sine of 150? At some point in time, all school systems give you this thing called the unit circle, and
Okay.
they want you to memorize every slice on this thing. There's 16 slices.
Okay.
There are 6 trig functions. So that's 96 things they want you to memorize.
Whoa.
Well, nobody memorizes 96 things from a list of 96 things. That's just not the way to memorize stuff. The way you want to
Mm-hmm.
memorize stuff is in batches of 3 or 4 items at a time.
Okay.
Okay? So let's talk about Sohcahtoa for these two triangles. What is
Okay.
the sine of 30 degrees?
The sine of 30 degrees would be 1 over 2.
Good. What's cosine of 30 degrees?
Root 3 over 2.
And the tangent of 30 degrees?
1 over root 3. Or you could do like 3,
Well,
um,
that the tangent of 30 degrees is 1 over root 3. Mathematics doesn't like irrational denominators, so I would have to rationalize that, and that becomes root 3 over 3.
but just one question.
Uh-huh.
Our teacher today, because yeah, he administrates like College Board, and helps out grading the SAT and such.
Uh-huh.
They accept radicals in the denominator now.
Terrific. I love it. I've always hated the fact that math does not accept that. And it becomes really apparent in trig why that's a problem.
Okay.
Because there's 3 other trig functions that are the inverse of these 3. Not the inverse, the reciprocal.
Mm-hmm.
What's the cotangent of 30 degrees?
The cotangent of 30 degrees would be 2 over 1.
No, it's cotangent is reciprocal of tangent.
Oh. Cotangent, yeah. It would be root 3 over 1.
Right. And notice that the fact that if I had not rationalized it, let's go back and not rationalize it, it actually makes it easier to come up with cotangent.
Mm-hmm.
In other words, had I rationalized this, then cotangent would need to be rationalized because now you still have a radical in the denominator. So
Yeah.
I'm tickled to death that they've changed their philosophy on that.
Mm-hmm.
The other three things that you have to memorize are the reciprocals. Over on the right, sine is 1
Okay.
over cosecant, cosine is 1 over secant, and tangent's 1 over cotangent. Now, the easiest one of those to remember is the tangent, clearly.
Okay.
Okay? And then I always had trouble figuring out, does the secant go with cosine or does it go with sine? Well, notice that there's an S and a C in both cases.
Okay.
There's an S there and a C there. There's an S there and a C there. So if you're ever tempted to put secant as the reciprocal of sine, you know it's wrong because it's got two S's.
Okay.
Okay? So that's the way
Yeah.
to memorize the reciprocal functions. Starting with cotangent, which goes with tangent, and then figuring out whether secant or cosecant goes with sine. So what's the cosecant of 30 degrees?
The cosecant of 30 degrees would be uh 2 over root 3.
No, 2 over 1. Remember, it's the reciprocal of sine. So if sine of 30 was 1 over 2, then cosecant has to be 2 over 1.
Because secant goes with cosine.
Right.
Okay.
So what's the secant of 30 degrees?
Would that be 2 over root 3?
Yes. And the fact that we don't have to worry about rationalizing them makes a big difference. Because let's look at this 45-45-90 triangle. What is the sine of 45 degrees?
The sine of 45 degrees?
Uh-huh.
It would be 1 over root 2.
Correct. Now, because of this oddball convention where they don't like irrational denominators, some school systems have actually changed this triangle on the right so that instead of it's this, it's square root of 2, square root of 2, and 2.
Huh.
And they did it specifically so that answers would come pre-rationalized. In other
Oh,
words,
okay.
now what's the sine of 45 degrees?
What's the sine of 45 degrees? It would be root 2 over 2.
Right. And notice that it doesn't matter what numbers I put on these two triangles. What matters is their relationship, their ratios. That's the only thing that matters. In other words, on this triangle over here, I can make that 10, 20, 10 root 3. And you get the same trig ratios. The sine of 30 degrees is still 1/2.
Okay.
Okay? So I call it the unit because the side opposite the smallest angle is always 1. And that makes it a little easier to memorize. In other words, if I know that's 1 and I know that's 1, well then that has to be square root of 2. And if I know that's 1 and that's root 3, then that has to be 2. So
Okay.
I really prefer the unit triangles where 1 is the smallest side because you always have a starting spot.
Okay.
Okay? So these two triangles now allow you, if you have these memorized along with their dimensions, and the dimensions are the hard part,
Mm-hmm.
then you know all 6 trig functions for 30 degrees, 45 degrees, and 60 degrees.
Okay.
Right? You can figure it out from what you see on this page.
Yeah.
In fact, let me erase everything that you don't need to memorize. So far, everything I have on here, you need to memorize. And when I say memorize it, there's an expression in trig. You don't want to memorize it. You want to know it. Just like you know your
Okay.
name. When somebody says,
Okay.
what is your name? You don't stop and think and try to access a part of your brain where your name is memorized.
Mm-hmm.
You know it. It's Nick Darrow. Okay?
Yeah.
Well, that's how good you want to get with trig functions. When I say, what's the sine of 60 degrees, you don't really want to have to pause and figure out SOH means opposite over hypotenuse. What's the sine of 60 degrees?
Opposite hypotenuse. Root 3 over 2.
Yeah. And you want to get to a point where you can do that instantly. You don't want to
Okay.
take 4 seconds to figure it out, okay?
Yeah.
Trust me. That the smartest, the best thing you can do in trig is to get these down so good that you can do them almost instantly when somebody asks you.
Okay.
Okay? Now, that's a good starting spot for trig because that gives you all of the first quadrant angles. And as long as we're talking about the unit circle, there's a reason they call it the unit circle also. It's because it has a radius of 1. Okay? In other words, if I draw a 30-degree angle here, and that distance is always 1, then notice that if I create a triangle, this
Mm-hmm.
is the x distance. In other words, if I try to figure out what the coordinates on the end of that ray are, well, the x-coordinate, what is the cosine of 30 equal to? Based on my
Cos
picture.
cosine of 30 is equal to x over 1, or yeah, x over 1.
Yeah, which means x equals the cosine of 30. So the x-coordinate on that point right there is the cosine of theta. And the y-coordinate is the sine of theta.
Okay.
Notice that the sine of 30 degrees would be opposite over 1, which would make the y-coordinate be sine of theta. So you end up with this relationship that on the unit circle, the x-coordinate is the cosine of theta, the y-coordinate is the sine of theta. Okay?
Okay.
Now, what that means is that it's even harder to memorize the unit circle
Yeah.
because they not only want you to know what all 6 trig functions of all angles are, and I don't mean all angles, I mean all angles that are a multiple of 30, 45, or 60. In other words,
Mm-hmm.
nobody ever expects you to memorize what the sine of 29 degrees is. That's not a common angle. But what
Okay.
they are going to expect you to know is the sine of any multiple of 30, 45, or 60 without a calculator.
Okay.
Okay? So if I'm filling out cosine of theta, I know the cosine of 30 degrees is square root of 3 over 2 based on this triangle up here on the left. And I know the sine of 30 degrees is 1/2. So what they are going to expect you to be able to do is label the x and y coordinates at every point.
Okay.
Like that. And that is the x and y coordinate of that point. It's square root of 3 over 2 is the x coordinate, and the y coordinate is 1/2.
Okay.
Okay? And then they'll expect you to memorize for 45 degrees, and then for 60 degrees. And then let's look at the quadrangles for just a second. The quadrangles are multiples of 90. So 90, 180, 270, 360, 450, any multiple of 90 degrees is called a quadrangle. Well, it's not that easy to figure out what the sine of 90 degrees is from our two triangles. There's actually is a way to do it, but it's kind of out of the box thinking, and I don't really want to confuse you at this point with memorizing that. However, there's an easy way to figure it out. What are the coordinates of that point right there that I just put the x through?
The coordinates of that point would be, isn't it just a little bit above 1/2 and then 0?
No, remember the radius of this circle is 1 everywhere.
Oh, okay, so it would be 1, 0.
Yeah. Now, since the first number is the cosine and the second number is the sine, well, that point represents an angle of 0 degrees, right?
Yeah.
So the cosine of 0 degrees is 1. And the sine of 0 degrees is 0.
Oh, okay.
Okay, now let's go up and look at this point. What are the coordinates of that point?
1, 0.
Yeah. No, actually.
0, 1.
Right. Okay.
Right.
So what is the cosine of 90 degrees?
The cosine would be 0 over 1?
Just 0.
Oh, just 0?
0 divided by anything is 0.
Yeah, 0.
Okay, what's the sine of 90 degrees?
1 over 1? So it's 1?
Just 1, exactly. In other words, you don't need the ratio. I notice you're putting it in ratios, but in this particular case, there is no ratio. The cosine is 0, the sine is 1. And that's all you need to memorize, okay? Now let's go to this point, which is 180 degrees. What are the coordinates of that point?
Negative 1, 0.
What's the cosine of 180 degrees?
Negative 1.
And the sine of 180 degrees?
0.
And finally, we'll look at this point, which is 270 degrees. What are the coordinates on that point?
0, negative 1.
So what's the cosine of 270 degrees?
0.
And the sine of 270?
Negative 1.
Now you know 30, 45, 60, 90, 180, and 270. And you know it based strictly on this picture. Now, I didn't used to teach it this way. At some point in trig, you have to memorize that curve right there.
Okay.
That is y equals sine x And you also have to memorize the cosine curve.
Okay.
Now, there's something very special about both of these curves. They both go to 3, we'll stay in degrees for a moment, not get to radians yet.
Okay.
This is the graphs of these two functions.
Huh. Okay.
And notice, this is 1, that's minus 1. This is 1, that's minus 1.
Okay.
Now looking at the graph, what's the sign of 0?
The sign of 0 would be 1.
No, look at the graph, not my unit circle, but the graph that I just drew.
Would it be 0?
Uh-huh. It's right
Okay.
there, right?
Yeah.
Okay, now each of these graphs get in the habit of quartering. In other words,
Okay.
there's 4 key points on each of these graphs. There's the end point, which is 360 degrees, but there's also the midpoint, which is 180. There's the midpoint between that, which is 90. There's the midpoint between that, which is 270. And it merely oscillates between -1 and 1. Both of them do. In
And
other words,
that's
is all I've drawn
okay.
is one period of this graph. In actuality, it continues on forever in both directions.
Okay.
Okay? In other words, the rest of it would keep going like that.
Is that because like a circle can go around in infinite times?
Yeah.
Like a number of times? Okay.
Yeah. In other words, the domain of both of these functions is all real numbers, negative infinity to positive infinity.
Yeah, okay.
But when we're talking about them, it's very useful to just look at one period.
Mm-hmm.
Because after one period, it just repeats. Okay? So if I said to you, what's the sine of 450 degrees? That's subtract 360, and that means it's the same as the sine of 90.
Oh, okay.
Okay? And those are called coterminal angles. In other words, the angle that's coterminal with 30 is 390.
Okay.
Also, minus 330 is coterminal with 30. As long as there's a difference of 360 degrees between the two numbers, they're coterminal.
Okay.
And so that's why the sine of 450 degrees is the same as the sine of 90. It's plus 1.
Okay.
Okay? Now, I still recommend that everybody memorize these two curves. And on the cosine curve, this midpoint, hold on, is 180. The other key points are 90 and 270.
Okay.
Okay? Notice that when you quarter it up, the quarter points coincide with either 1 or 0.
Uh-huh.
In other words, if we're looking at the sine of 0 is 0, the sine of 90 is 1, the sine of 180 is 0, the sine of 270 is minus 1, the sine of 360 is 0. Same answers we get from our unit circle. Okay? But if you don't have these two curves memorized perfectly, you can always figure out those quadrangles from the unit circle the way we did it the first time.
Okay.
Okay? It's helpful to have both. And trust me, at some point you're going to need to memorize both of these curves.
Okay.
And once you do, then you won't need to use this other method. But it's
Okay.
always nice to have multiple methods whenever you're studying math. You know, just
Yeah.
check yourself. In other words, this unit circle over here confirms what these two graphs are. And you can almost think of the unit circle as if you had a string that made up that unit circle and you tugged on the string, you'd end up with these two curves over here.
Yeah.
Okay, that's one way to think about it. So now I've given you the ability to know what the sine of 30, 45, 60, 90, and all multiples of 90 are. So the only thing left is to figure out the angles that are multiples of 30, like 150. 150 is a multiple of 30, right?
Yeah.
But it's not a quadrangle.
No.
150 would be that angle right there.
Okay.
Okay. Now, as long as I've started on this, let's finish it because this is going to help you immensely.
Yeah, it has.
Memorize this unit circle here. And when you get to a point where you know all of the angles in the unit circle that are multiples of 30, 45, or 60. What I've just labeled there are the quadrant numbers.
Okay.
First quadrant, they go counterclockwise. First quadrant, second quadrant, third quadrant, fourth quadrant.
Okay. Is there a reason for them going counterclockwise, or is that just
convention? Just convention.
Okay.
They wouldn't have to. They could go clockwise. But notice that our angles go counterclockwise also.
Yeah.
That's 30. In other words, we start from the x-axis and we go counterclockwise. If we start from the x-axis and we go clockwise, that's actually a minus 30-degree angle.
Okay.
Okay. Happens to be the same as a 330-degree angle, as it should be, since they're coterminal. So they're going to be exactly 360 apart. But it shows you that trig tends to work counterclockwise, not clockwise.
Okay.
Okay. Now, there's a couple of things. When I'm looking at that 150-degree angle, the trig functions are actually the same as this 30-degree angle.
Okay.
Almost the same. They're based on this formula right here. You want to take whatever angle you have and subtract it from 180, and that's the angle you're going to figure the trig function on. So if I said to you, what's the sine of 150, what would it be?
Sine of 150. Wouldn't it be 30?
Be the same as the sine of 30. At least the same numerical value. In other words, it would be 1/2, right?
Yeah. Okay.
Well, there's something else that goes with these quadrants, and that is all students take calculus. And what this A means is that all 6 trig functions are positive in the first quadrant.
Okay, yeah.
In the second quadrant, only sine and its reciprocal, cosecant, are positive.
Okay, why is that?
Everything else is negative. So if I said to you, what's the cosine of 150 degrees? First of all, let's write this. The sine of 30, excuse me, I wanted to do it this way. The sine of 150, and then in parentheses, I use this as my equivalent first quadrant angle. So I put the 30 in parentheses. So the sine of 30 is 1/2 That's its numerical value. And then I figure out what its plus or minus sign is. Well, I'm in the second quadrant. Sine is positive, so it's positive 1/2.
Okay.
Now let's look at cosine. If I said, what's the cosine of 150? Well, based on this 180 minus theta, that's the same as 30. And we know the cosine of 30, based on our two triangles, is √3/2. That's its numerical value. But what is its plus or minus sign in the second quadrant?
Wouldn't it be minus?
Has to be minus, because only sine and cosecant are plus in the second quadrant.
Okay.
So that's the way I'm going to do all angles in the unit circle. When I get to the third quadrant, instead of 180 minus theta, it becomes theta minus 180. And when I get to the fourth quadrant, it's 360 minus theta. Okay? So if you memorize everything you see, let me erase this. What you're looking at right now, you want to memorize everything on the lower part of this page.
Okay.
And I'll even draw a unit circle in there to help. Okay? So let's drill you on this. You can't get too good at this. Tell me what the sine of 210 is.
Sine of 210.
First thing you want to do is figure out which quadrant it's in.
It is going to be in the third quadrant.
Okay, so what is its equivalent first quadrant angle?
30.
And what's the sine of 30?
1/2.
And what is its plus or minus sign?
It would be a plus.
Not in the third quadrant.
Oh, a minus.
Be a minus. That's the way we're going to do every angle, is using that exact logic.
Okay.
You've just memorized the unit circle, all 96 spots, believe it or not.
Oh.
And I'll prove it to you. I'm going to give you some random ones. Tell me what the tangent of 225 is. Which
225.
quadrant?
That'll be in the third quadrant.
What's its equivalent angle?
And the first quadrant would be 45.
Okay, now let's go back and look at those two triangles. If you don't have them memorized, what's the tangent of 45?
1/1, so that'd just be 1.
Okay, and then what is its plus or minus sign?
It would be minus.
Third quadrant. All students take calculus. Don't forget the ASTC. Tangent is positive in the third.
Oh. Okay.
Be plus 1.
Okay.
Okay. Now, there's another way. They didn't magically come up with this 180 minus theta, theta minus 180, and 360 minus theta. You can see that if I draw a 150-degree angle, it's this angle that's the 180 minus theta, right?
Yeah.
Well, if I complete that by drawing a triangle, you can see why sine is positive. The hypotenuse is always positive.
Okay.
The unit circle is your first exposure to polar coordinates.
Yeah.
You've never had polar coordinates, correct?
No.
You'll get it at the after trig. One of the reasons they like to actually teach trig in the first semester is because you can't do polar coordinates or vectors or parametric equations until you've had trig. So if they give that to you in the first semester, you get to do all of those at the end of trig, at the end of that first semester. Whereas having pre-calc in the first semester, they're not going to do the whole semester on trig. They're only going to do about 2/3 of it. And the last third, you'll get into polar equations and the polar coordinate system, which is different than the XY coordinate system.
Okay.
This is your first exposure to it. And one of the consequences is that this ray always has a positive number, never a negative number. So that's always positive 1, no matter where the angle is. Even the 225 that was in the third quadrant, that's a positive 1.
Okay.
And the sine of 30 degrees is the opposite over 1. Well, that y-coordinate is a positive measurement, correct?
Yeah.
That's why sine is positive in the second quadrant. Now,
Okay.
and it's also why cosine is negative. Notice that the x-coordinate here is a negative measurement. And so I'm putting a negative x measurement over 1. So cosine's negative in the second quadrant.
Okay.
Okay. Now, why is tangent positive in the third quadrant? Well, let's draw a 225 degree angle. That's that angle there.
Okay.
Making this reference angle 225 minus 180. That's 45 degrees. So that's its equivalent first quadrant angle. And notice what tangent is. Tangent is opposite over adjacent. Well, the opposite is a negative measurement. The adjacent is a negative measurement. Negative divided by negative is positive. That's why tangent's positive in the third quadrant and why everything else is negative.
Okay.
Remember, this is always a +1 there.
Yeah.
Okay. And so you have multiple methods of remembering this. The one I find the absolute easiest is all students take calculus. Just starting with the first quadrant, counting counterclockwise. Now, you don't really need to think of these. These are called reference triangles. These little triangles that I've been drawing. Reference triangle being the triangle or the reference angle, excuse me, that being the angle that is made with the x-axis. In other words, alpha is the reference angle. And you get alpha by 180 minus theta, this being theta.
Okay.
Okay. So everything that I've written on this page, if you just memorize it alone, you can figure out all of these. Let's do another one.
Okay.
What's the sine of 330?
The sine of 330 would be 180 minus that. It would be in the, wouldn't it be in the fourth quadrant?
Correct.
Um,
So you use 360 minus theta.
and that would be 30.
Okay, and the sine of 30 we know is 1/2.
And if it's a sine, it's a plus.
Not if it's in the fourth quadrant.
Oh, if it's in
Figure
the,
out which quadrant it's in.
yeah.
And notice that only cosine is positive in the fourth quadrant. That means sine is negative and tangent's negative.
Oh, okay, okay.
It's negative 1/2.
Okay.
Okay?
So, okay.
Yeah. And that's all you need to memorize these 16 slices of the unit circle. And notice what we're memorizing here. We're memorizing this triangle where there's 3 things to memorize. We're memorizing this triangle where there's 3 things to memorize. we're memorizing 180 minus theta in the second, theta minus 180 in the third, and 360 minus theta in the fourth. That's another 3 things to memorize. And then we're memorizing all students take calculus, 4 things to memorize. So by memorizing batches of 3 or 4 things, we're able to memorize all 16 slices of the unit circle.
Yeah, okay.
As simple as that. In other words, if I gave you a 16-digit credit card number to memorize, you wouldn't memorize it as 16 digits. Nobody would. They would chop it up, right, into 4 groups of 4. That's the way you would memorize it. They've actually done studies that say that the human brain doesn't memorize more than 7 things very well. And one of the reasons phone numbers started with 7 digits is because people can remember 7 digits fairly easily, but you start getting 8, 9, 10, 11, and it's much harder. Okay, so if we're trying to memorize all 16, and you know what I mean by all 16 slices of the unit circle, right?
Yeah. In
other words, that's 30, 45, 60, 90, 120, 135, 150, 180, and so forth. And they're going to want you to know all 6 trig functions at all 16 slices. Yeah. Well, this is the way to memorize. And they may teach you this method. I'm quite certain they will. But some of the school systems seem intent on giving you this giant unit circle, dividing it up into 16 slices, and want you to memorize each coordinate at each end point. Well, it's helpful to know that that is the cosine of theta, comma, sine of theta. So all you really have to do is memorize the cosine and sine of theta is the x and y coordinate. And so if this is 30 degrees, what are the coordinates on this point that I just put an x through?
30 degrees. That'd be 60.
What's the cosine of 30? Oh. That's the x coordinate, is the cosine of 30.
Okay, the cosine of 30 would be... Oh, I'm nuts.
Here, let me bring the triangle up. What's the cosine of 30?
It would be root 3 over 2.
Okay. So that first point is root 3 over 2. And the second point is the sine of 30, which we know to be 1/2.
And that would be, yeah, 1/2.
Okay. So when they test you on the unit circle, you got to know coordinates on that point, on that point, on that point, on that point, and so forth around the whole thing.
Okay.
Okay. And they'll want you to know tangent also. Well, tangent is equal to sine divided by cosine.
Okay.
Okay. So if I wanted to know the tangent of 30, well, I can take 1/2 divided by square root of 3 over 2, and I get 1 over square root of 3.
Okay.
And you can also always figure out the tangent from these 2 triangles also. And to me, it's actually easier to figure out tangent from these 2 triangles rather than knowing tangent is sine divided by cosine.
Okay.
Okay. So that lets you know the cosine of any angle, the sine of any angle. You can figure out the tangent of any angle. And then, of course, the other 3 trig functions are just those reciprocals. So if I wanted to know what the cosecant of 30 degrees is, I look at what's the reciprocal of sine. Well, sine is 1/2. The reciprocal must be 2.
2. Okay.
Now, the other thing that you may not be immediately aware of is that the sign of the reciprocal is always the same as the sign of its reciprocal. So if the sign is negative 1/2, then the cosecant has to be negative 2.
Okay.
Okay? So now we have a method for all 6 trig functions at all of these angles.
Okay.
And this second one here is 45. And this third one is 60. And the other one is 90. Okay? So just from what we've talked about today, you're now in a position where you can draw the unit circle and not only label the x and y coordinates at all of these points, but you can give all 6 trig functions at each of those points also.
Mm-hmm.
Theoretically. Okay?
Yeah.
Now, when I say that, I mean given the fact that you've memorized everything that I've written here. Now, that's going to take you some time to do.
Uh-huh.
The 2 triangles, you've been working with those 2 triangles for 3 years now. You actually should have that memorized already.
Okay, yeah.
Okay, and of course the key thing here is the dimensions, not the fact that it's a 30, 60, 90 triangle. It's the fact that opposite the 30 is 1, opposite the 60 is √3, and opposite the hypotenuse is 2. Okay.
Oh, yeah.
And like I said, you could put any multiples of these down. In other words, I could write 2, 4, 2√3, and it makes all my trig functions the same. The sine of 30 is still 2/4.
Okay, yeah.
Okay? So whether we use the multiple or whether we use the unit dimensions doesn't matter. And it's certainly easier to memorize the unit dimensions. So this is the way I dimension my 2 what I call special unit triangles. The 45-45-90 and the 30-60-90. These 2 triangles are huge in math.
Yeah.
And that's why they concentrate so heavily on them in terms of being able to do all of these trig functions without a calculator, which is important. I'm not quite sure. I do know why, but in other words, somebody might say, well, gosh, you always have your calculator. How come you can't just put in sine of 210 and not go through all of this manipulation? There's a good reason for it. It's hard to explain until you get further into trig, but there is a good reason to memorize these common angles.
Yeah.
And these curves on the left also, the sine and the cosine curve, how each one is quartered, and the fact, what's the range of the sine of x? The domain was all real numbers. What's the range?
Of sine of x?
Look at this.
Isn't it from...
over here on the left?
Yeah.
What's its range?
Would it be from 0 to 360 or from like 0 to 1?
-1 to 1. Remember range?
Oh, -1 to 1.
Range is the y coordinates that you're looking at.
Oh, yeah. Okay.
Domain is the x coordinates.
Okay.
So what's the domain of cosine x?
The domain of cosine x. Isn't it still all real numbers?
Correct. What's the range of cosine x?
-1 to 1.
Correct. What this means is if somebody says to you the sine of theta equals 1.2, impossible. There is no angle that the sine of the angle is equal to 1.2. In fact, it's never greater than 1. It's never less than -1.
Okay.
For both sine and cosine. Now, just as since we're talking about the graphs, let me give you one other graph, which is tangent. Tangent actually has vertical asymptotes, as the other four, or everything has vertical asymptotes except sine and cosine. Notice there were none there. Tangent does this. Goes from, what's the, and it repeats every pi. In other words, every 180 degrees. Now, that's minus 90, that's plus 90, and that's 270. So if I were to draw 2 periods of tangent, it would look like that.
Okay.
And of course, if I were to draw 10 periods of tangent, I could go both ways. It's like sine and cosine in that you can take the tangent of 5,000 degrees if you want.
Okay.
Okay. And what's the domain of tangent?
The domain is negative 90 to 90?
Well, you could say that it's all real numbers except...
Oh, okay. You can say it's all real numbers except negative 90, 90, and 270?
Exactly. Multiples of 180.
Okay.
Basically.
Yeah.
There's a specific way they have of writing that. We won't get into that now, but in other words, it can be any number you want as long as it's not on one of these vertical asymptotes.
Okay.
What's the range of tangent?
Isn't it all real numbers?
Yes, negative infinity to positive infinity. Unlike sine and cosine.
Uh-huh.
Okay. Now, this goes minus 90 to 90. Let's talk about negative angles just for a moment. She'll get into those very quickly. As I said, if I start from the x-axis and go clockwise, that is a negative 45 degree angle.
Okay.
Okay. And there's a property of sine and cosine. You remember even and odd functions?
Yes.
Well, sine is odd. So is tangent.
Okay.
And what that means is that the sine of minus an angle is equal to minus the sine of the angle.
Okay.
Same thing with tangent. Tangent of minus x equals minus tan of x. Cosine is even. Cosine, the cosine of minus x is actually equal to the cosine of x, not minus the cosine of x. So by using these odd and even properties, you can easily handle negative angles. So what's the sine of minus 30 degrees?
Sine of minus 30 degrees. Wouldn't that still be 1 over 2 or negative 1 over 2?
Yeah, it's the same as, no, it's negative 1 over 2. In other words, what I just wrote there is true. The sine of minus 30 is the same as the minus sine of 30. And we know the sine of 30 is 1/2. So that would be minus 1/2.
Okay.
Now, I could do it the hard way. The hard way being, let me first of all erase this 45, which could be confusing, make it minus 30. The hard way would be, well, what is this angle here? That's 330. So I could say that the sine of minus 30 has to be the same as its coterminal angle. Well, its coterminal angle is 330. You see why those two angles are coterminal?
Yeah.
Okay. Any angles that are separated by 360 720,
Okay.
whatever the next multiple of that is, are coterminal. 10.
Okay.
So 360, 720, and 1080 are all coterminal angles, as minus 30 is also coterminal with 330. So I know these two have to be the same, but if I do it this way, that's the hard way, because now I got to go and I got to say, well, 360 minus 330 is the same as the sine of 30, which is 1/2. Then I have to say, well, it's in the fourth quadrant. I can see it's in the fourth quadrant, so it has to be negative. So I get the negative sign, I get the negative 1/2 answer regardless of how I do it. But notice that it's much easier to get it from there.
Yeah.
Without going through turning it into the sine of 330 and then using all of those formulas for each quadrant to figure out that that's negative 1/2. It's better to use the fact that they're odd and even.
Uh-huh.
Okay?
Okay.
All right. One last thing I want to tell you tonight, because you mentioned that they've given you this already. This is an if and only if statement.
Okay.
If the sine of 30 degrees equals 1/2, then the inverse sine of 1/2 equals 30 degrees.
Okay.
You've had inverse trig functions, right?
Yes.
Just briefly, one day's worth?
Yeah. Uh-huh.
Okay. These two are basically equivalent. They're not quite equivalent, but this is the way to look at it, is that we take trig functions of angles to come up with ratios. We take inverse trig functions of ratios to come up with angles.
Okay.
For example, you're familiar with the 3, 4, 5 triangle, I'm sure.
Yes, yeah.
Another special right triangle. But what they've never taught you is what theta is. Right?
Yeah, I was wondering
You know what
about that.
theta is?
No, I was wondering about that. I was like,
Yeah, because it's not important. What's important is it's at a 3, 4, 5 triangle. That angle is not particularly important. But if I wanted to figure out that angle, I would take the inverse sine
oh, yeah, we went over this.
of 3/5.
Okay, yeah.
And that turns out, now I do need to put that into a calculator. This is not something they expect you to memorize, but it's approximately 37 degrees. It's actually like 37 point and a lot of decimals.
Mm-hmm.
Okay? But if we had a problem where we needed to know that angle, then I would want to know my inverse trig functions.
Yeah, okay.
That also is the inverse cosine of 4/5. Same thing, 37 degrees.
Okay.
Okay? So that's what inverse trig functions are. Is inverse trig functions find angles. Trig functions are taken of angles to find ratios.
Okay.
Okay? And then one last thing is the difference between degrees and radians. Have they talked to you about that yet?
Yeah, but they don't really explain it too much.
It's hard to explain. Basically, you multiply by either pi over 180 or 180 over pi.
And one of them is one of them.
Going from 90 degrees and I want to convert it, I multiply by pi over 180 because that gets rid of the degrees and leaves me with pi over 2 radians.
Okay.
If I want pi over 2 radians and I want to change it to degrees, I'm going to multiply it by 180 over pi because that gets rid of the radians and leaves me with degrees, and that gives me 90 degrees.
Okay.
So the pi over 180 over pi is the way to convert degrees to radians.
Okay.
And the tough part is explaining what the difference between radians and degrees are. That's a hard thing mathematically. It's not the same as the difference between meters and feet.
Okay.
Meters and feet are the same kind of units. There's just a conversion factor. Doesn't matter which one you use. Degrees and radians, a whole different story.
Oh.
Radians are actually a number.
Okay.
Okay? So we won't get into that tonight, but
okay.
That gives you my Trig 101 tutoring session.
Cool.
And,
yeah, that was really helpful.
Well, it should be very helpful to you. And the only thing I would say is memorize most everything you see on this page.
Okay.
Certainly Sohcahtoa, the two triangles, all the reciprocal relationships, the unit circle, the two graphs.
Yeah.
That's for starters. And if and this part of the unit circle here, where it's the 180 minus theta, the theta minus 180, the 360 minus theta, and the ASTC. Memorize all of that. When I say memorize it, I mean be able to create it from scratch. If I gave you a blank piece of paper and I said, draw this, you want to be able to do it.
Okay.
Once you can do that, you've got 50% of trig figured out. And I'm not exaggerating.
Well, okay.
Okay?
Okay. Thank you, Mr. Cohen.
You're welcome, and I'll talk to you Wednesday.
Yep. Talk to you Wednesday.
Okay, bye-bye.
Bye-bye.